Okay, so now we're going to talk about moles to mass, volume, or particle conversions. So we want to make sure we have a balanced reaction. We're going to identify our given and the unknown. We're going to write a roadmap, how we're going to go from moles A to moles B. And then, do we need conversions? So that's the dimensional analysis. And we have to remember our conversions, moles to molar mass for mass in grams, 1 mole, 22.4 liters. And then Avogadro's number for particles, ions, molecules, etc. So moles to mass. So we're given the following. We have how many grams of aluminum are produced if 2.58 moles of aluminum oxide are completely decomposed. So we're starting with moles. And we're going to grams of aluminum. Actually, maybe we'll just do. All right, so our given, let's write that down. Our given is the 2.58 moles. So we can get our formula from this, so we don't have to come up with it. Al2O3, aluminum oxide. And then we're going to aluminum, so our unknown is aluminum, grams of aluminum. So we have to figure out how we're going to get there by our roadmap, okay? So we're starting in moles. So if you were following the roadmap, the green roadmap, you would start with moles of substance A, which is aluminum oxide. And then we're going to convert to moles of aluminum. And then we're going to go to the grams of aluminum. That's our roadmap. So let's start with the 2.58 moles of aluminum oxide. So we're going to do stoichiometry, which means we're going to set it up like the tree method. So our conversion to go moles to moles means the moles of what we started with, which is the 2 moles of Al2O3, going to moles of aluminum. So we're going here to here. So 4 moles of aluminum goes on top. So the thing I want goes on top. So we're going for 1 mole of aluminum down here. And then we want to go to grams to get to grams of aluminum. So we're going to look at our periodic table. So it's 26.98. Let's see. $154. Oops, sorry. And that's equal. All right. So we're going to put in our calculator. So we're going to do 2.58 times 4 times 26.98154 divided by 2. So we end up with 139.22. We round it to 3 significant figures. That's 139 grams of aluminum. So that's our answer. So we're going to do it by the tree method. So notice that See how I have aluminum oxide? They kind of cancel out. So that's like, this is one problem going to moles, and then this is the second problem, and this is grams of aluminum. All right, we'll go to the next thing. That's our amount. All right, so it says, given the following reaction, what volume of oxygen is produced if 2.58 moles of aluminum oxide are completely decomposed? So we're starting with the 2.58 moles of aluminum oxide, and we're going to oxygen. So we're starting here, and we're going there. So our given is 2.58 moles of aluminum oxide. Our unknown is liters of O2, oxygen. So our road map, is going to be, we're going to go from moles of aluminum oxide to moles of oxygen, and then liters of oxygen. So if we're going to do a mole problem first, we're like in the middle of your map. So we're going to start with the 2.58 moles of aluminum oxide. The moles of what I want goes on top. So we want oxygen, so that goes on top. And then moles of aluminum oxide goes on the bottom. We want volume, so we're going to go from moles of oxygen to 22.4 liters of oxygen. So we need 2.58 times 3 times 22.4 divided by 2. Okay, so we end up with 86.7. We're rounding it, 86.7 liters of O2. And that should be our answer.